Alright, welcome to another episode of Graham's Networking Lessons. We're going to start a new series now. I have some friends in Austin that are really technical, and they wanted to get into machine learning, so I agreed to do this course with them. So every week we're going to do a chapter, I believe. So so under lessons here, we've got 8 chapters. So every week we'll be doing all 8. We'll be doing a complete one of these chapters. So for this week it's going to be your first models. And so it looks like there's 8 lessons within this chapter, so we'll be doing all of the lessons there. So this is a free course. It's available for anyone. It's just course.fast.ai. If anyone from this channel would like to do this with me, any of my subscribers, after I post this video, I'll post it this morning, so if you see it this afternoon or tomorrow and you can get this whole chapter done by Monday at 7, hey, you're a subscriber to this channel, you're a friend of mine, so just maybe comment on the video or some way. There might be a way I can let you in on the discussion group. But anyways, let's just get started on this, and hopefully just here Saturday morning finish lesson 1 so I'm ready to go by Monday. So let's read the overview, and then we'll read the and then we'll keep going. So okay, so this is Practical Deep Learning for Coders. Deep Learning for Coders with Fast AI and PyTorch. AI Applications Without a PhD, the book and the course. Table of contents, how do I get started? Is this course for me? Who we are, the software you'll be using, what you'll learn. Welcome to Practical Deep Learning for Coders. This website covers the book and the 2020 version of the course, which are designed to work closely together. If you haven't got the book, you can buy it here, but it's also freely available as interactive Jupyter notebooks. Read on to learn how to access them. Okay, good. Let's take a look at the book. Maybe we can see some reviews on it. Hopefully it's got some good reviews. So I don't see any reviews, which is odd because usually there's reviews. Here's some reviews. So yeah, we got some good reviews, got some bad reviews. Let's look at some 3-star reviews. I don't see any 3-star reviews, even though it said it had some. It looks like there's no reviews. Okay, let's look at 2-star. Okay, well that's interesting. It looks like they were able to somehow delete their reviews, but have them still show up there. But anyways, looks good. It's free. I like it. So let's continue. How do I get started? If you're ready to dive in right now, here's how to get started. If you want to know more about this course, read the next sections and then come back here. Oh, that's interesting. So come back here. What does that mean? So okay. You know what? Let's do that. So I understand what they're saying here. If you want to learn more about the course, read this section here. Is this course for me? And read this section here. Who we are, and then come back and read this here, so to watch the videos. So let's copy that and search for it so we know exactly where to come back. And yeah, let's learn more about the course. So is this course for me? Thank you for letting us join you on your deep learning journey, however far along that you may be. And I am a little bit along the path. I know some of the concepts just by watching some YouTube videos. I've tried to do a bit of the actual coding, but funny enough, the application I was actually trying to use machine learning for didn't require machine learning. It just required basically data analysis and computer vision. But I thought it would require some machine learning, but it really did not. And for anyone really curious about that, you can just go to my GitHub. And this is the project I'm talking about. I used to work on it kind of fairly industriously, but there were problems with creating. Well, I don't want to create an account. I want to sign into my existing account. There we go. So I was fairly industrious on this juggling coach. So what I wanted it to do is teach you juggling by identifying problems and helping you avoid to practice mistakes. So let's say you're juggling and you're constantly, like all crooked and your pattern's asymmetrical and stuff. I wanted this to be able to tell you that, because often when you're doing something in real time like that, and the ultimate goal is to get it away from juggling and just be a general. You want to swing a golf club, it'll help you with that. You want to play a musical instrument, help you with that. And there are ones for shooting free throws and playing golf already. But there's certainly not one for juggling. But this was both a exercise to help me learn to juggle better, and to help me learn this sort of technology, which is pretty interesting to me. But you can see, unfortunately, my last update was 8 months ago. It did end up working fairly well and getting me a graph, and I can show it here. Just show it off. Just because I'm a little bit proud of it. If we look at the code here. I don't typically write code this way, with a comment above every single line. The reason it's written this way and not kind of in a style more typical to me. Here you can see kind of a more typical style than me, because this I made up kind of purely on my own. So the reason it's not that way here is because I followed a object tracking tutorial from the Pi image search. So that code comes courtesy of Adrian Rosbrock, which I encourage anyone interested in computer vision to look at his tutorials, and perhaps even sign up for his courses. I believe he does he does machine learning as well. But yeah, this guy is definitely the absolute real deal. This guy is a PhD, really good person to learn from. So yep, and basically just through his tutorials, you can see what I have been able to accomplish. So let's show that. So let's go down to Python projects. Okay, and then this is going to be juggling coach. Okay, so I believe the README. Yep, the README does tell me how to run it. I'm in Windows, so I've got to do Pi-3. Linux, the whole word Python is usually used, and then 3 without a space. But my environment is kind of wonky. Most people don't develop in a Windows environment, but I just use what I got. That's kind of my philosophy, is if you got it, use it. I think other people tend to have different philosophies sometimes. Oops, so it looks like I opened a Linux terminal to my Linux subsystem. So that's going to be, yeah. So let me open the PowerShell window. There we go. Oops, so we've got another problem here. We've got no, oh, I think I didn't activate the I thought I had a virtual environment for this, but apparently I do not. Okay, well that's interesting. I thought I had a virtual environment. I do not. Let's create one. So we're going to do pi3 -m VNV, and then we'll just name it VNV. There's no reason to. I mean, if it's named VNV, it's going to be VNV. So, oops, and it's not going to be pi3. It's going to be pi-3. Okay, so now we've got a VNV, so let's activate the virtual environment. So we're going to do VN or source VNV, and then scripts, and then activate. Okay, let's go into VNV. Okay, so that is going to be the extension, but okay, so we've got a problem here. Source is not going to be the keyword to be used. So let's all right, let's do a Google search. So instead of source, let's take a look. Source VNV Windows. Oh, I think you just don't need the word source. I remember now. You can just do VNV. Exactly. So now you can see I'm in that virtual environment. So let's install the missing modules. So first, let's just do a dir to see what's in there. Okay, and then let's do a py3. And then we're going to do the juggling, oops, not py3, we're going to do py-3, and then do the juggling coach. Okay, so now we're seeing that we're missing a module named imutls, so let's do a pi-3-m pip install imutils. Okay, so it looks like I installed it. Let me do a pip update as well, just because it's out of date. Okay, but we did get imutils successfully installed. Okay, so let's see if it runs now. And this is a big fat diversion. I definitely need to get back to the course because I've got to get it finished by Monday. But I'm pretty proud of this project, so I definitely want to show it off in some way. Okay, so now we're missing another one. It's called Scipy, so let's get that. Alright, and now I think there's a way to automatically generate the requirements file. So I will look into that once I get this to the point where, because I've got to pass it the video too, so once I get to the point where it gives me an error for not passing that argument, I will shift gears and try to generate that requirements.txt file so it's easier to set up later for somebody. Well, you know what? I've got some time, so I'll just do it right now. Auto generate requirements.txt. So let's see here. Pip freeze. There we go. Perfect. Oh, that's the README. I want to do requirements.txt. Oops. So okay. So I did pip. So that's not going to work. So I need to do pi-3-m pip freeze. Okay, and then redirect the output. That's what this means to requirements.txt. There we go. So now hopefully there's some data in there. Yep, we can see we've got data in that file. So let's see what made it in there. Okay, so here's everything I've got installed. It's a bunch of extra crap that's not necessary. So I'm kind of tempted to just filter it out. But I think for now I'll just leave it. So let's see if we're at the point where it's complaining about the missing argument. Oh, I added an extra -m. Okay, yep. So it's complaining about the missing argument. So let's pass it that argument. Oops, so it looks like it couldn't find. Oh, I gotta give it -b, I think. Aha! So I got it to work. We see all the data coming up. It'll show me, I thought it would show me the video. It's not doing that right now, but it will show me a graph afterwards. So I'm going to pause this. I got to take a quick break, and I'll be right back. Here's the graph, but I will be right back. All right, so I am back, and here's the results. So let's take a look at the video that was analyzed. So it was in here, and it was here. So let's just watch the video quick. It's really short, but Okay, so here's the video that was analyzed. So just me in my apartment when I was a little bit thinner than I am now. I'm working on it though, pre-quarantine. But you can see I've got the balls showing up really clearly against the background. That's because they are glow balls. So here's the analysis of that. Now I'm still working on getting these to align, and you'll notice that they're negative numbers, otherwise it would show it to me upside down. But this is a pretty good start, I think. And basically what I want this for is I want to see the variation, because an ideal juggling pattern, you just have two peaks, and you have everything very nice and consistent. But you can see I have a lot of variation in this graph, and that doesn't necessarily mean that I have a lot of variation, because if these were actually to scale and were numbers that actually made sense, I would this might appear to be very, very thin. So kind of the ultimate end goal is there's a mathematical equation that a really great juggler, Jack Kelvin, juggle. Well, let me just show the book. So it's called When Balls Collide. Yeah. So really great juggler, Jack Kelvin, teamed up with a really great juggler and a really great economist, Arthur Lobel, and they developed math to determine the quality of a juggling pattern. So my end goal is to be able to use that math in this program here to give you a score on your juggling, and hopefully to give you a score in real time every few catches, and shout it out to you, and to be able to predict how many catches you'll get based on your current score. So I just want to bring this wonderful math that they kind of developed. I want to bring that to a practical application is basically my goal. So okay, so that's good. I was able to get that to work. Let me do a push, because I did make some changes. I got the pip freeze, and I created a virtual environment. So we're going to do Git Status, and then we're going to do dir. Yep, and then we'll do Git Status again. Okay, and then we'll do a git add. We're just going to add everything that's there, even though the requirements file is still kind of wonky and we've got these extra files. I'm just going to add extra ones. Okay, and it looks like there's differences between, because I've got such a wonky Windows environment, we're going to have extra line ending characters in there that probably won't be recognized in other environments, but this is just for me. This is my own personal project, so that's going to be fine. Let's do another Git Status. Okay, so we can see all these. Okay, these are part of my virtual environments. So we got a bunch of new files added, but that's because I'm uploading my virtual environment. I'm not sure if that's typical actually. Let me ask that to Google. Is it typical to upload your virtual environments to GitHub? Okay, and I might need to ask the question differently. Okay, so here we go. So is it? No, it's not necessary to upload virtual env file on GitHub. Okay, so you're meant to add it to. And the reason it's not necessary is because you can add it to git ignore. Yeah, because they basically have your virtual environment already just through this file here. So yeah, you know what? I'm gonna get rid of that on there. So I'm gonna do git and then help. Okay, and now I want to do git. I did a git add, so I want to do a git remove on that. Yeah, so git rm. Oh, and I got it. It's a directory, so I've got to do a -r. Okay, now let's do a git status. Oops, so it's still it's no longer it looks like it didn't okay, so yeah, let's unstage. So let's do a git reset head v and -r vnv. Okay, we didn't need the -r there, so there we go. We've got the untracked files. So let's see if we can add that to git ignore. Okay, so it looks like we can just do a git ignore file here. Let's find the git ignore. So we're going to do a so we've got to figure out how to see hidden files here. Okay, so I know it's going to be named, so dot. Okay, so yep, here we go. So let's do a cd.git, and then a dir, and then we're going to go cd config. Oh, let's do a cat config. cd refs. No? Okay, so I don't know how to ignore a folder in Git, so I'm going to look that up. How to ignore a folder in Git. Okay, so I've got to create a new file. It's not going to be there. So it's going to be in my projects directory. And then into the file, we're going to add the name of the directory. So really nice and easy. Let's do it. So it's not going to be in the .git file. It's going to be in the folder. It's going to be in the, well, it is going to be in the project folder if it were in the .git folder, but it's just going to be in the main project folder. So let's do notepad, and then it's going to be .git ignore. Yep, create a new file, and it's going to be in v dash. Perfect. Okay, so now we've got that added to git ignore. So let's do a git status. Oh, okay, and let's add that to git ignore as well. So notepad dot git ignore, and we'll add git ignore to git ignore. Actually, no. Let's keep that there, because it's just a let's track it, and let's push that, because I think they'll want this in there, because they don't want to push there. So we'll lend a hand to the person to anyone else who may have done this. Another thing I would like to do is ignore the py cache folder as well. I don't think that's necessary. Oops, so, but I'm going to need to unstage it first, because it can't be ignored if it's staged, I believe. Perfect. Yep, and we can see it's completely ignored. We don't even have the option to stage it or track it. Okay, so yep, that looks good to me. Let's do a git add dot again, so that we get that git ignore file there, help out the next person, so that they don't accidentally push up their PyCache folder or virtual environment folder to my repo. And now we've got the requirements.txt. We've got no changes to the code or anything like that. Yeah, let's do it, because it was working just fine. Let's just run it quick one more time, make sure it's not just randomly hosed, and there's some issue where I'd be pushing it up to the repo where it's not working. So we'll just make extra sure that it's working, even though we saw that it worked before. And I like running it. I think it's kind of cool. We get all this data back, and then we get normally you would actually see the video running as well. I think I have that as an option to toggle on or off, and I toggled it off. But sure enough, it's creating the graph. My next step, of course, is to create the scales. So let's make a good comment. So git commit -m, and we'll say fixing basic environmental stuff, such as VNV and requirements.txt, and git ignore. The next step would be to get the graph X and Y to scale so that it more accurately represents the juggling. Okay, so that's the end of that. You can see how easily distractible I am, but okay, let's verify that it made it up to my Git repo. It did, and we've got the new. Oops! It looks like we've got. Oh, right, because the PyCache was. was left over from before. So yeah, so you can see I didn't modify that at all. So I guess it would be nice to just delete this PyCache. So let's do that quick before moving on. Okay, we gotta do okay, we can just do A for yes to all. Okay, now we don't have that anymore. So, and we'll do a git status. Okay, and we'll do a git add so that the change we made is going to be staged to be committed. So we'll do a git commit -m. We'll say PyCache folder not necessary to be stored on GitHub. Okay, git push origin master. Okay, and I think I'm just using master branch. Yeah, I don't have any extra branches. So let me think here. Okay, let me run it again because I'm gonna have I should have no changes set up to commit when I run it again, because although I'll have extra folders, the PyCache folder, I've added that to my git ignore, so it won't go up there. But let's see if my most recent push made it up there. Yep, so we can see PyCache folder is not necessarily stored on GitHub, so it's gone. And now let's run the script again. We'll see it come back, and then we'll see if I do a git status, it'll still be nothing to commit because it's in my ignore. Okay, so we got the fancy graph. Again, the next step is going to be making these numbers more to scale so that it more accurately represents what's actually going on. You can see here it's kind of flattened and like widened, so it's really not what you see on the screen when you watch the video. So we're going to be changing that. I also have this kind of tracking to the ball going up and down that needs a lot of work. So yeah, and I have a catch counter here, very inaccurate. I had many more than 30 catches. So but if I do a dir, you'll see I've got that PyCache again. But if I do a git status, yep, there's nothing to commit since I added that to my git ignore. Okay, so let's go back to the original task at hand, which I'm really easily distractible in case you haven't noticed. And we're going to be reading, is this course for me, and who we are, and then going back and reading this section and then skipping down to this section But I need a quick break. I'm very hungry right now. So I will, in fact, eat. So I'm going to pause it and I'll come back. Oops, and it looks like my find went away. Oh. Okay, there it is. So, yep. Okay, we're good. I'm gonna pause it, come back after I've eaten, and continue with this. Hopefully, get all the way through chapter 1. All right, so I am back. Let's continue on with this course. There's someone kind of revving their engine outside, so I'll put these on. Let's read the "Is this course for me?" Thank you for letting us. Okay, for some reason these. Okay, there we go. Thank you for letting us join you on your deep learning journey, however far along that you may be. Previous Fast AI courses have been studied by hundreds of thousands of students from all walks of life, from all parts of the world. Many students have told us about how they've become multiple gold medal winners of international machine learning competitions, received offers from top companies, and having research papers published. For instance, Isaac Demashkri told us that he had been playing around with machine learning for a couple of years without really grokking it, then went through the Fast AI Part 1 course late last year and it clicked for me. Okay, who is this person? Is he a professional, computer professional from Russia? And what does grokking mean? Okay, so he's a PhD software engineer. And they just said this was not for PhDs. He seems like a PhD software engineer who's had like a long career with this sort of stuff. That seems to me to be a bit misleading and unfair, but that's okay. Oh, I like this word though. Understand intuitively or by empathy. Because that kind of is where you want to get when you learn something, just to where it's intuitive and you don't really have to think about kind of how you learned it or go back and reference things. It's just intuitive. So I like that word, but I'm kind of I feel a little bit misled by the course for touting as their success story somebody who would have been successful with or without the course. He went on to achieve first place in the prestigious international RA2-DREAM challenge competition. He developed a multi-stage deep learning method for scoring radiographic hand and foot joint damage in rheumatoid arthritis, taking advantage of the Fast AI library. It doesn't matter if you don't come from a technical or mathematical background, though it's okay if you do. We wrote this course to make deep learning accessible to as many people as possible. The only prerequisite is that you know how to code. A year of experience is enough, preferably in Python, and that you have at least followed a high school math course. The first 3 chapters have been explicitly written in a way that will allow executives, product managers, etc. to understand the most important things they'll need to know about deep learning. If that's you, just skip over the code in those sections. Wait, I don't understand this sentence. So the first 3 chapters has been explicitly written in a way that will allow executives, product managers, etc. to understand the most important things they'll need to know about deep learning. If that's you, as in if you are... Oh, I see. Okay, yeah. So if you're an executive, product manager, something like that, management who doesn't work with code, then you can just read the first 3 chapters. You can just read the text, and you can skip over the code, and you'll just get up to speed with what deep learning is and all that sort of thing. So deep learning is a computer technique to extract and transform data, with use cases ranging from human speech recognition to animal imagery classification by using multiple layers of neural networks. A lot of people assume that you need all kinds of hard-to-find stuff to get great results with deep learning, but as you'll see in this course, those people are wrong. Here's a few things you absolutely don't need to do world-class deep learning. So here's a myth of things that you might need. So according to the myth, you might need lots of math, you might need lots of data, and you might need lots of expensive computers. But the truth is, you just need high school math. That's sufficient. That they have seen record-breaking results with less than 50 items of data, and that you can get what you need for state-of-the-art work for free. Deep learning has power, flexibility, and simplicity. That's why we believe it should be applied across many disciplines. These include the social and physical sciences, the arts, medicine, finance, scientific resource, and many more. Here's a list of some of the thousands of tasks in different areas at which deep learning, or methods heavily using deep learning, is now the best in the world. Okay, so these are all things that if you do, you're definitely going to need to know deep learning. So the first one is natural language processing, NLP. Answering questions, speech recognition, summarizing documents, classifying documents, finding names, dates, etc. In documents, searching for articles mentioning a concept. Computer vision, satellite and drone imagery interpretation, e.g. for disaster reliance. Face recognition, image captioning, reading traffic signs, locating pedestrians and vehicles in autonomous vehicles. Medicine, finding anomalies in radiology images, including CT, MRI, and X-ray images. Counting features in pathology slides. Measuring features in ultrasounds. Diagnosing diabetic retinopathy. Biology, folding proteins, classifying proteins, many genomic tasks such as tumor-neutral sequencing and classifying clinically actionable genetic mutations, cell classification, analyzing protein/protein interactions, image generation, colorizing images, increasing image resolution, removing noise from images, converting images to art in the style of famous artists, recommendation systems, web search, product recommendations, homepage layout, playing games, chess, Go, most Atari games, many real-time strategy games, robotics, handling objects that are challenging to locate, e.g. transparent, shiny, lacking texture, or hard to pick up. Other applications, financial and logistical forecasting, text-to-speech, and much more. Who we are Sylvian Gugger and Jeremy Howard, your guides on this journey. We are the co-authors of Fast AI, the software that you'll be using throughout this course. Jeremy has been using and teaching machine learning for around 30 years. He started using neural networks 25 years ago. During this time, he has led many companies and projects that have machine learning at their core, including founding the first company to focus on deep learning and medicine, Enlithic, and taking on the role of president and chief scientist of the world's largest machine learning community, Kaggle. He is the co-founder, along with Dr. Rachel Thomas, of Fast.ai, the organization that built the course this course is based on. I think they mean library instead of course. I think that's a typo there. Sylvian has written 10 math books covering the entire advanced French maths curriculum. He is now a researcher at Hugging Face and was previously a researcher at Fast.ai. Okay, well this doesn't seem like a myth anymore that you need to know math. We care a lot about teaching. In this course, we start by showing how to use a complete working, very usable, state-of-the-art deep learning network to solve real-world problems by using simple, expressive tools. And then we gradually dig deeper and deeper into understanding how those tools are made and how the tools that make those tools are made, and so on. We always teaching through examples. Okay, well, we got some strikes here, but let's just keep going. And these aren't strikes; these are just basic typos. Everyone makes typos, so it's not a big deal. We ensure that there is a context and a purpose that you can understand intuitively, rather than starting with algebraic symbol manipulation. Although in my opinion, algebraic symbol manipulation is actually somewhat intuitive. Okay, so let's go back up now that we finished that, and let's continue reading this section and then skip down. So to watch the videos, click on lessons on the lessons section in the navigation sidebar. The lessons all have searchable transcripts. Click transcript search in the top right panel to search for a word or phrase, and then click it to jump straight to the video at the time that appears in the transcript. The videos are all captioned and also translated into Chinese and Spanish. While watching the video, click the CC button to turn them on and off, and the setting button to change the language. Each video covers a chapter from the book. The entirety of every chapter of the book is available as an interactive Jupyter Notebook. Jupyter Notebook is the most popular tool for doing data science in Python, for good reason. It is powerful, flexible, and easy to use. We think you'll love it. Since the most important thing for learning deep learning is writing code and experimenting, it's important that you have a great platform for experimenting with code. To get started, we recommend using a Jupyter server from one of the recommended online platforms. Colab, a popular free service from Google. Google have changed the notebook platform quite a lot, so keyboard shortcuts are different and not everything works. Example, much of chapter 2 doesn't work because Colab doesn't support creating web app GUIs. Gradient, unlike Colab, this is a real Jupyter notebook, so everything in the course works. It also provides space to save your notebooks and models. However, sometimes the free servers get overloaded, and when that happens, it's impossible to connect. If you are interested in the experience of running a full Linux server, you can consider datacrunch.io. Very new service, so we don't know how good it is, no setup required. Extremely good value and extremely fast GPUs. Or Google Cloud, extremely popular service, very reliable, but the fastest GPUs are far more expensive. We strongly suggest using one of the recommended online platforms for running the notebooks, and not use your own computer unless you're very experienced with Linux system administration and handling GPU drivers, CUDA, and so forth. If you need help, there's a wonderful online community ready to help you at forums.fast.ai. Before asking a question on the forums, search carefully to see if your question has been answered before. The form system won't let you post until you spent a few minutes on the site reading existing topics. The software you'll be using. In this course, you'll be using PyTorch and FastAI. We've completed hundreds of machine learning projects using dozens of different packages and many different programming languages. At fast.ai, we have written courses using most of the main deep learning and machine learning packages used today. We spent over 1,000 hours testing PyTorch before deciding that we would use it for future courses, software development, and research. PyTorch is now the world's fastest growing deep learning library and is already used for most research papers at top conferences. PyTorch works best as a low-level foundation library, providing the basic operations for higher level functionality. The FastAI library is the most popular library for adding this higher level functionality on top of PyTorch. In this course, as we go deeper and deeper into the foundations of deep learning, we will also go deeper and deeper into the layers of FastAI. This course covers version 2 of the FastAI library, which is a from-scratch rewrite providing many unique features. What you'll learn. After finishing this course, you will know how to train models that achieve state-of-the-art results in computer vision, including image classification. For example, classifying pet photos by breed, image localization and detection, example, finding where the animals in the image are. Natural language processing, NLP, including document classification, for example, movie reviews, sentiment analysis, and language modeling. Tabular data, for example, sales prediction, with categorical data, continuous data, and mixed data, including time series. Collaborative filtering, e.g. movie recommendation. How to turn your models into web applications and deploy them. How and why deep learning models work, and how to use that knowledge to improve the accuracy, speed, and reliability of your models. The latest deep learning techniques that really matter in practice. How to implement stochastic gradient descent and a complete training loop from scratch. How to think about the ethical implications of your work to help ensure that you're making the world a better place and that your work isn't misused for harm. This is a big one, especially nowadays with the protests going on. There's a lot of applications where they'll scan a crowd with deep learning or whatever, and they'll pick out kind of the organizers of the crowd devoted to expressing their First Amendment rights, and they'll be the first people kind of taken out of that crowd. And, you know, to me, something like that is very harmful, because if if you're in the, one of the main, it's the First Amendment of the Constitution. You have a right. Let's get distracted here just because of how crazy things are right now in the United States. We're going to just read the First Amendment of the Constitution. Congress shall make no law respecting an establishment of religion or prohibiting the free exercise thereof, or abridging the freedom of speech or of the press, or the right of people to peacefully to assemble. So this is a way where it could go awry, just violating the spirit of the First Amendment, the right of the people to peacefully assemble. You can develop a AI application to pick faces out of the crowd, and the people who would organize this peaceful assembly, you could go after and target. And I believe there are companies working on that and putting that out already. So this is going to be a really interesting part of the course to learn about. Here are some of the techniques covered. Don't worry if none of these words mean anything to you yet. You'll learn them all soon. Random forests and gradient boosting, affine functions and nonlinearities, parameters and activations, random initialization and transfer learning, SGD, momentum, atom, and other optimizers, convolutions, batch normalization, dropout, data augmentation, weight decay, image classification and regression, entity and word embeddings, recurrent neural networks, RNNs, segmentation, and much more. Okay, so I finished the overview, so the next part to read will be the information about collab and gradient. So let's stop the video for now and upload this one, because I don't know how much space I have left to record. I'm worried I'm going to lose this video, and I want to kind of organize my postings. So this is going to be the getting started video for this course. So stay tuned for the next section, which is going to be notebook servers. So I'll see you then.